This is a Diebold AccuVote TS electronic voting machine of the type used in elections in several U.S. states. We studied this machine in our laboratory at Princeton University to evaluate its security and its suitability for conducting elections. The detailed results of our study, including a full technical paper, are available at itpolicy.princeton.edu/voting. The behavior of voting machines is controlled by computer software. The software that tallies votes on this machine was written by Diebold. Our study shows that a criminal who can inject malicious software into this voting machine can control how the votes are tallied. His malicious software can steal votes, and it can cover its tracks so that the theft cannot be detected. To illustrate this danger, we have created in our laboratory a demonstration software program that steals votes. This video will show our demonstration software in operation. We will also show how a criminal can inject malicious software into a voting machine, and how he can create a computer virus that spreads itself between voting machines, injecting malicious software on every machine it infects. We will now show how to steal votes in a simulated election. On the morning of Election Day, the voting machine awaits instructions. The machine appears to be functioning normally, but, unbeknownst to any observer, it contains malicious software that will steal votes. The machine greets the election workers normally. At this point, the election worker can perform so-called logic and accuracy tests that are supposed to determine whether the machine is functioning correctly. Logic and accuracy testing is essentially a pretend election. The worker casts pretend ballots, and then the machine counts the pretend votes. The election worker makes sure that the pretend count is correct. Our vote-stealing software can tell that the worker is doing logic and accuracy testing, so this is not a real election. It allows the pretend votes to be counted correctly, so that the machine passes the test. Everything still looks normal. Now the election worker tells the machine to start the election. The machine prints out a paper tape showing that no votes have been recorded yet. The election has begun. The first voter approaches the machine to cast his vote. The election workers have given him a voter card, which will allow him to cast one vote. He inserts the voter card into the machine, and the machine presents him with a ballot. In this example election, there are two candidates for president, George Washington and Benedict Arnold. The voter chooses George Washington. The machine asks him to confirm his vote, and he does so. The machine ejects the voter card, after marking it as used. That's one vote for George Washington. 4 more voters cast their votes. They vote for George Washington, Benedict Arnold, George Washington, and George Washington. The correct result for this election is George Washington 4 votes, Benedict Arnold 1 vote. Election day is now over. An election worker approaches the machine, inserts a supervisor card, and tells the machine to end the election. The machine prints out a paper tape announcing the results. The tape shows that Benedict Arnold won the election, 3 votes to 2. This result is incorrect. Malicious software stole votes from George Washington and gave them to Benedict Arnold. The voting machine recorded the election results on its internal memory and on a removable memory card. A poll worker opens the side of the machine and removes the memory card. The memory card, when examined by technicians, also shows that Benedict Arnold won the election 3 votes to 2. Every record kept by the voting machine shows the same fraudulent result. Arnold 3, Washington 2.